Tangent line problem is a precursor to calculus, okay? And so are limits for that matter. So what we're going to talk about today is how we can use the limits that we've been learning about to help us solve problems. Because in the real world, life isn't just lines, okay? There's lots of curves, equations with curves and dips and twists and so forth, okay? Life is not linear. So first of all, what are your observations about this particular function? Kind of looks like possibly like a tangent, right? Or not really. Right, we've got a tangent. Okay, so what do you mean by a tangent? Well, here's a hint. Let me write the equation out so you can see it better. X cubed plus 4x squared plus x minus 6 has 3 zeros. What are those zeros? 1, -2, and -3. It's hard to see. You guys are a ways back. So it has 3 zeros. Okay. Fourth power, right? So it tells us at most we have 3 zeros. It's increasing for a while, and it's decreasing for a while, right? And then it's increasing again, right? Remember when we graphed these things? We did in algebra 2. I know we graphed rational functions. I'm not sure that we did a lot with polynomials. Okay? So then I've got this line, this dashed line, and I have it touching this polynomial, this function, in exactly one spot. So let's look at this guy and see what's happening. Oops, I meant to go click on it. Let's try it with my mouse on my keyboard. All right, so this is called a tangent line. And we'll talk about it in just a moment and why it's called a tangent line. Okay? But what do you notice about the slope of that red dashed line? Okay? Almost even with the blue line at that point, right? And what would you characterize the slope as? Positive slope. Is it steep? Okay, very steep, right? So we've got a steep slope at this point, right? If we move this point, what happens to the slope of our line? It changes, exactly. It's still positive, right? Is it as steep? No. If we move that point some more, sorry, almost 0, right? Much less steep now, and it's still positive, right? Okay. Unfortunately, I can't get it to be exactly 0. I've tried. Okay. Kind of reminds you of the guy on the tight wire or the high wire on the circus, right? Tightrope. Huh. Crazy. Crazy. But now what's happened to our slope? It's become negative. Okay. So could we find the slope of the line at those particular points? Could we estimate it? Yeah. Okay. And that's kind of the idea behind this. So let's go back to our slide here and talk about what's a secant and what's a tangent. These are terms from last year in geometry. Okay. Anybody remember what a secant was and what a tangent was? Not so much in the pre-calculus version of it, but what in general was a secant and a tangent? I threw a circle up here to help you remember. Touches the circle in exactly one spot, and what does the secant do? Yep, 2 stops goes through it. Okay, may go through the diameter, right? But it may not. Okay, so the black line is a tangent and the red line is a, okay. So we have a secant and a tangent, okay? In calculus and pre-calculus, the tangent line, because it's a curve and not a circle, can actually intersect it in 2 spots. But what we're looking at is we're trying to find out information about the slope of that tangent line. Because when you're working with these functions, they are going to be real world types of problems, okay? If we shoot a rocket, okay, what is its velocity at this particular point in time? Okay, we'll have an equation of a line, right? An equation of that curve, of that distance traveled, right? Or the height that the rocket achieves. And we can find out what its height, what its slope is, okay, what its velocity is at any given time. Okay, so that's where the foundations of calculus comes from. A lot of applicable physics-based approaches to things. Okay, and this is just the foundation for that. So a tangent line approximates the slope of a graph at any given point. Okay, so what do you think the slope of the tangent to this curve is at the point -2, 0? Okay, first of all, is it positive or negative? Negative. Okay, so we think the slope is negative. Okay, and from here to, looks like it intersects here pretty well, right? We have gone down 1, 2, 3, and over 1, right? So -3. Okay, works great if we've got a nice graph paper, right, with grids. Unfortunately, in your book, they're going to ask you to estimate it, and they won't provide the grid, so you'll have to do your best guess. Okay, but there are more precise methods. Okay, same curve. Okay, but what do you think this? Oh, different curve now. Okay, what is the slope of the graph at -1, -2 of that tangent line? -2. We went down 2 and over 1. You could immediately spot a place, or you went up 2 and left 1. So our slope is -2. Okay? Estimates, but pretty darn good estimates. Okay? Here's the same curve now. Different point on that curve. What do you think the slope is here? Okay? You're saying, is it positive or negative? So positive something, right? Okay? How do we find it? 1, 2, 3, 4, 1. We've risen 1, 2, 3, 4, and ran 1. Our change in y was 4. Our change in x was 1. This is part of it. Okay? So far, so good? Haven't lost anybody. Okay. So, how do we use this? Okay, so I mentioned a secant and a tangent, right? That tangent line is our best guess, our best estimate, our best answer for the slope of a curve. Okay, the problem is trying to get that tangent line. Okay, to get in a line that is exactly tangent at exactly that spot, only touches it in one place. So what we do is we say, let's mathematically derive this. And let's use what's called a secant, because a secant will touch that curve in 2 spots. Okay? So the slope becomes more and more accurate the closer those points come together. The slope of the secant is the change in y divided by the change in x. And the change in y is f of x plus h, we've moved it a little bit horizontally, minus f of x, our original function, all divided by h. Because this is my x movement, right? This is my y movement. Okay, so I've moved horizontally a distance of h, and I've moved vertically a distance of whatever f plus h is, f of x plus h, minus my original f of x. This y minus this y. So I'm finding the slope. Now it becomes more and more accurate the smaller we make the h, right? This guy's going to have a closer slope than this one to the original. This one's slope, this secant line, will be closer to the slope of the graph because we've narrowed that distance. And what happens when we've narrowed it so much that the h is no longer there? Now instead of a secant, we have a tangent. And that's going to be the very accurate, perfect value, not an estimate, of that slope. Okay. And the h is actually going to be, here's the key, okay? What have we been studying thus far, this chapter? Limits. So if we can plug this into our equation and then manipulate it so the h is not in the denominator anymore, right? Then we can take the limit as h approaches 0 to make it into teeny tiny and small and not even exist, right? And then we'll know the slope of the line at that tangent point. Okay, does that make sense? That's the process behind it. Now, what I'm going to teach you today is going to seem cumbersome and tedious, okay? And what Mr. Schmidt will teach you next year, once he's walked you through this again, is going to make you say, oh my gosh, why is this so easy and why did you make us do this? But we want you to understand the process behind it, and then you'll learn the shortcuts and you'll be like, I love shortcuts, this is amazing, this is so much easier, okay? So don't come back and stone me because I taught you the hard way, but that's the process, so you understand where it comes from. Okay? All right, here we go. So we want to find the slope of the graph of f of x equals x squared minus 3 at the point -1, -2. So our slope formula was what? Change in y over change in x, right? Okay, that change in x was our h. What's our change in y? Not h, but x. Okay. So we're going to plug in our x's here, right? And then we have to work with that function. Find So what's actually happening here is we're going to say f of, what is our x value? -1 plus h minus f of -1 over h. Okay. But what does our function say to do? Our function says that we're going to square our x's and subtract 3, right? So this was our piece, right? So we're going to take the -1 plus h and square it and subtract 3. And then we're going to take away our x squared minus 3. So -1 squared minus 3. Right, because what's happening is this is now our new x, okay? And this was the old x, okay? So what is negative 1 plus h quantity squared? Take it times itself, right? Okay, negative 1 times negative 1. Negative 1 times a positive h times a negative 1, and h times an h. Everybody with me on that first piece? Okay, we're taking away 3. And then if we take a negative 1 and square it, we'll get positive 1. 1 minus 3 is negative 2, and a negative negative 2 is going to be plus 2. Okay? So negative h and negative h is gone, right? Or negative 2h. Write this over here. So we'll have negative 3 plus 2 plus 1, 0. And we'll have an h squared minus 2h. Okay, what's the greatest common factor of that numerator? H. So we'll take the h out, and we have h minus 2. We're dividing that by h. The h's cancel, and we no longer have an h in the denominator. We just have an h minus 2. And now that we can do that, now that we've removed the h from the denominator, we can take the limit as h goes to 0 to make that a tangent. Okay, because we want to make that gap between the h's to be nothing. Okay, why 0? Because we want to make this gap become tiny to where it doesn't exist anymore. Okay, so it's always going to be 0. Whoops, wrong way. Okay, so our slope is negative 2. Okay, because when we take the limit as h goes to 0 of h minus 2, we make h 0, and our answer becomes good. Yes, this is nothing different than what you were doing yesterday. It's just that you have to come up with the equation now. Okay? So we still want to do what we can to make the h's disappear from the denominator. Okay? But we're finding the slope of that line, of that curve. It is. Yep. So we're taking that limit. And that limit, when we make the h approach 0, gives us the tangent line, not a secant line. So, yeah, those problems that we were doing, we were finding, yes, we were finding the slope. You didn't know what you were doing. Okay? All right. Does that make sense to everyone? What questions do you have? It will eventually, yes, come, well, we will have some that do have fractions. Okay? But the goal is to not be dividing by 0 anymore. We didn't need to use a negative 2. Right. Yep. All we needed was this x value because we're just trying to find out what is the slope of the tangent when x is negative 1. Okay? Now, this is very zeroed in on one particular point. Okay? Let me show you how we do it for any point. Okay? Yep. The previous one, we were looking just specifically for one point. And now we're going to find that slope of the whole curve for any given point. So you can plug in multiple points for x and find the slope at any point along there. Okay? And that's the way I'm most familiar and comfortable with. I just do this with the equation in general and then plug a point in. All right, so here we go. We want to find the slope of the graph of f of x equals x squared plus 1 for any point. Doesn't matter what the point is. Okay. So my slope is equal to f of x plus h minus f of x all over h, right? They like to call this the slope of the secant line. That's what the little SEC means. You'll use it enough that you'll know it. Okay? So what we do is everywhere we see x squared, we just put x plus h. Okay? So we're going to take this first one, and everywhere we see x, we're going to put x plus h. And we're going to add 1. That's the first one. That's f of x plus h. All I did was replace x plus h with every x I see. And then I've got to take away, and I like to put it in brackets so I don't forget that I'm taking away everything. I'm going to take away my f of x. And I put it all over h. Now the hardest part is squaring that first thing out. If we square x plus h, take it times itself, and hopefully you've done enough of these over the years that you can immediately just say this is x squared plus 2xh. You multiply them together and double them, and then you square the last one. Or you can FOIL it off to the side, and you'll get the same thing. Okay? Then we've got this plus 1 we can't lose. And then if I take away x squared plus 1, that quantity, I'll get a negative x squared and a negative 1. X squareds are gone. Yep. 1s are gone. So what's left? What do they have in common? I take out the h. And once we've reduced it and made them cancel, now we can take the limit because there's no h in the denominator anymore. So what is the limit as h goes to 0 of 2x plus h? 2x, because h is now gone. We do direct substitution here. H is gone, and we get 2x. Nope, there's no h in it anymore. So we keep that x. Now, that's the equation for any time I want to find the slope of the graph of this guy. So this is my new equation. I'm going to call it f prime of x, and I'll show you why in just a minute, because we've changed it, right? It's not the original equation now. This is the equation of the tangent line anywhere along that curve. Okay? Doesn't matter where we're at along that curve, that's the equation. So now if I asked you to plug a point in, you could do that. If x is 0, what's the slope? 0, right? Which makes sense, right? Because at x squared plus 1, that's a parabola opening up, shifted 1 up, right? Quick sketch. At x is 0, my slope will be 0. Okay? At x is 1, my slope will be a positive 2. At x is negative 1, my slope would be a negative 2. At x is 2, 2 times 2 is 4. It's a steeper slope. It's got a slope of 4. Okay, so this is your answer. Okay, And then we can put any numbers we want to in for x. Okay? So we're not going to what? No. This is the hard way. Yeah, there's actually an easier way. Because you need to know the definition of the derivative. Okay? After one problem, you won't get it. Okay? Okay, so h was that arbitrary value that we said, let's move it a little bit. We're trying to find the slope, right? But it's really hard to come up with the equation of this tangent unless we use the original equation of our function and mathematically manipulate it. Okay? So my h was my horizontal distance away between these 2 points. Okay? And my f of x plus h minus that f of x is my vertical distance. Okay, that's my y, my change in y. Okay, and then the reason that we perform a limit operation on it is that we want to make that h be 0, so it actually becomes the tangent line. Okay, not a secant line. Okay. I just wanted to show you that this is why the slope is this way. Okay, this is just kind of a, guess what? At 0, we've got a horizontal. Okay, at 1, we'll have something with a slope of 2. At 2, we'd have something with a slope of 4. It's getting steeper. Okay, just to give you an idea of how that relates. Okay, but this is your final answer. This is all you have to find. Okay, thank you. All right. So this is nothing new. Okay, this is just the formal definition of the derivative of a function. Okay, that's just what we just did. Okay, used to find slope, used to find rates of change. Okay, acceleration, velocity, those types of things depending on what equations you have. Okay, and we like to call it the we like to call it the derivative, and this is just the formal way of writing it, f prime. Okay, there are other ways to write it as well. We can call it dy dx. Okay, many books, and our book will use this terminology as well. Okay, and that's just the change in y versus the change in x, right? Dy dx. Okay. All right, so we've got this written down. We're good. Okay. Let's give you another example. This one will be a little more difficult because we've got more going on. Okay. So now we want to find the derivative. Okay, the slope of the line. That's what the f prime is. Yep, the dy dx. Okay, it's a prime. It is actually a half, yeah. Okay. Mm-hmm. And that one was just finding the equation for any old point, doesn't matter which. Okay. We're going to do the same thing and find f prime of x, and then we're going to plug in -1 for x. So there's 2 steps here. Okay. So this one before was plugging in, just finding the slope for one particular point. Okay. And we only plugged numbers in, we didn't have our variable. Okay. And then this one, we actually found the equation with x's and h's in it. Okay. And that's what we're going to be doing here, is we're going to be finding the equation with x's and h's in it, and then eventually plugging in our -1. Okay. So what's our formula? What's our formula for finding the derivative? So f prime of x, or you can call it dy dx, is going to be equal to, so I have to do what? F of, yep. And we take the limit as h approaches 0. Okay. same thing as f prime. Okay? It's just easier to say, I want you to, once you found f prime of x, nothing. I'm just formally giving it to you in this way. Taking you baby steps so you understand where we're going. Because if I jumped to this right away, you would have said, what in the heck are we doing? Okay? Got it written down? Yep. Just a little bit more complex equation. Okay? All right, so here we go. Everywhere we see x, we're going to put in x plus h. Okay? So we'll have, yep, first time through, everywhere you see x, you put x plus h. So we'll have x plus h squared plus x plus h minus 2. And then we've got to take away, and it might be good to put it in brackets so you know where this is coming from. Gentlemen. Now we're going to put in x squared plus x minus 2 all over h. For the second one, we're taking our f of x plus h and we're taking away our f of x. Yep. So this is the first one with x plus h everywhere we saw x. This is the second one with x wherever we see x. Okay. All over h. Okay. So we should know how to square this, right? X squared, multiply them together and double them. 2xh, h squared, right? Plus x plus h minus 2, just like the other one. Minus x squared minus x plus 2 this time when we take a negative times a negative, all over h. X squareds are gone. We have a positive x and a negative x, they're gone. A positive 2 and a negative 2, they're gone. So what are we left with? Plus an h, right? Yep, there's another h now. Okay, so we've got a 2xh plus h squared plus h all over h. How does that factor? Good. H 2x plus h plus 1 over h. H's are gone. Now that we no longer have an h in the denominator, we're good to take the limit. And we plug in 0 for every h we see. And what's my derivative? 2x plus 1. That's the equation of the slope of the tangent line for any place on that curve. And the last portion says, now tell me what happens. What's the slope at negative 1? So negative 1. Because 2 times negative 1 is negative 2 plus 1 is negative 1. We're not plugging in 0 this time. We're plugging in, yep. Okay. Okay. So then we plug in the negative 1 for x. So f prime of negative 1 is 2 times negative 1 plus 1. Okay? We're good? Okay. Let's throw one more at you. Now fraction. Last example. definition of the derivative. All right, so we know it's supposed to be f of x plus h minus f of x over h, right? So everywhere we see an x, we have to plug in x plus h in this first part, right? So we're going to have a 1 over x plus h minus, now we're going to put in our x, all over h. So we just took this, and everywhere we have an h, or have an x, we put in an h. Got a fraction now. We got that. And then we are dividing by h. So now we've got to get, how do we simplify something like that? Because it was always on the bottom. We just didn't have a fraction above it before. Okay. Everywhere we see x, we have to plug in x plus h. Thank you. Okay. So far, so good? Okay. So what's our common denominator on this in the numerator? X plus h and x, right? So this one needs an x. This one needs an x plus h. Now they have a common denominator of x and x plus h. Okay, this guy is x times 1, so we get x. Careful with this negative 1. The negative 1 is being multiplied by each of those. So minus x minus h, right? And then we are all over h. This one came from here. And then the negative 1 was distributed to both. So we can cross those out. Okay, these guys are gone. X and negative x is gone. Okay, so I have a negative h over x, x plus h, all over h over 1. Because when you have a fraction over a fraction, you can invert and multiply, right? Okay, so that's going to help us invert and multiply. So when we invert and multiply, these guys are gone. And this is nice because the h's will cancel, right? So we have negative 1 over x times x plus h. Can we take the limit now? Not breaking any rules? When h is 0, we will have negative 1 over x times x plus 0. So negative 1 over x squared. That is my derivative. And it's not asking us to apply it at any point. Okay, so we're done. Okay, good. I don't think I thought that the first time I ever saw this, so good. Okay, so there's the assignment. Some of them are just looking at it and deciding what the slope is. Okay, so there aren't a lot of problems.